Hello, I wasn't expecting to make this kind of video, but this is in response to a video that Critical Think made just a couple of days ago. And in that video, he analyzed the video that FlatzoidFE had put out and the whole controversy about how many frames were removed and all of that stuff. And that was probably related to a few other videos that Mr. Sensible had put out in a live stream, analyzed the footage, and even got FlatzoidFE to come in and have a chat. And then Mr. Sensible then made another video and released that yesterday or thereabouts. And I thought I was going to take a look at it as well to see what I could do and to hopefully create a common reference point that everybody could use going forward talking about this subject. And so thanks to the links that Critical Think provided in the description to this video, I found the video on Rhetoric's website along with the live stream and the subsequent follow-up in response to what FlatzoidFE had done. For those who don't really know what FlatzoidFE has done, he had taken the video that Rhetoric had put out and did some slight editing to it to make it appear like the Earth was flat, and he said that there is no curvature due to the inferior mirage and all that stuff. And so this is the video from FlatzoidFE. And just for context, in the first go through, he shows the original video uncut. And so here's the first pass through that he did. Then FlatzoidFE says this is where the apparent horizon is and all that other stuff. But more important, what he did was he removed a bunch of frames at this point showing the splash on the replay like that. And that's all documented in Rhetoric's live video that he did. It's done in Critical Think's video, Mr. Sensible's video, now mine, etc. The video I'm doing today is not really talking about this, although I am going to address that. But the main thing that I wanted to address here was that I wanted a common point of reference. I'm not going to show you exactly all of the scripts involved, and this video is probably going to go out before I write up the documentation. Once I had the video downloaded, I was able to use a tool like FFmpeg, and there are some options that are available that lets you save every video frame as a separate image. I used the tool EXIF tool that lets you query just about any kind of media type out there. It will give you all of the metadata along with the format types and the data rate and frame rate of the media in question if it's a video. And so I was able to use this tool to get some of the information available. And then finally, the last tool that I ended up using was ImageMagick. And this is a set of tools that will let you take an image, do some manipulation, and output it. I basically had a series of shell scripts that I wrote that would go through, and for each of the images extracted from here, I was able to use ImageMagick to overlay text on top of it and to output the file into a separate directory. And I was also able to use ImageMagick to stack two images together, and I'll show that in a second, but it allows me to show just how synchronized two videos are. So in the end, I took the video that Rhetoric had put out, and I had to reduce the size, including putting a letterbox around the outside to match the size that FlatzoidFE had put out. And what I also did was I used the ImageMagick to overlay some text on each individual frame for the context of the point of reference. And so as you can see, this frame comes from Rhetoric original YouTube video with this URL. That video happened to have 29.97 frames per second. The timestamp is this much into the video, and the frame number was 6533. And if I jump ahead to the next one, you can see it provides a nice point of reference so that you can narrow down to the exact frame. I did the same for FlatzoidFE, and you can see that it's a little bit harder to see the text here overlaid on top of the water, but it should still be good enough to serve the purpose. This video ID is from FlatzoidFE. He put out 30 frames a second, not 29.97. Here is the timestamp, and the frame is 6990. And I can jump ahead and show the exact same kind of thing that I showed just a few minutes ago for Rhetoric. So finally, I wanted to take both of these images, both from FlatzoidFE and from Rhetoric, locate the corresponding frame from each of the videos, and then I could, through a shell script, pair those two videos together and telling ImageMagick to stack the two images on top of each other. Here was the original video at 1280 by 720 from Rhetoric that I then shrunk down in size to 800 by 480. That would correspond to the same size of video from FlatzoidFE. And then finally, I was able to stack the two together. Once I had identified that frame 5250 from FlatzoidFE came from the same frame as frame 6520 of Rhetoric. This is what it looks like when it's stacked together. And I also am going to include a separate video clip of the two of them 3 frames out of sequence. So here you can see that I just chose a slightly different one. So 6523 from Reds corresponded to 5256 from Flatzoid. And you can see that the detail of this looks like a buoy isn't quite perfectly lined up like it was for this one. And you'll really be able to see what it looks like when I show the video clip. I'm going to play those clips at the end of this video, but the purpose of this video wasn't really to show the two video clips merged and combined together like I'm going to show. It was really first to talk about showing how to go about going forward if there is another controversy like this, to start using a process like this so that we can all have a common frame of reference when we start talking about it. When we start a common frame of reference, when there are clips from two different videos that may or may not be cut or modified or altered like this. The other thing that I wanted to point out in this video, however, I also went to the effort of doing a bit of an analysis on the video itself to see just where the capsule had splashed down in the water. Keep in mind that this one here is the high resolution from Reds, and I was only interested in this portion, and because it was higher resolution, I didn't want all of the extra frames extracted taking up disk space. So I ended up extracting only 1,000 frames around the splashdown in the high resolution. And in fact, if you check the description, I'm going to make this video available right away because it's already done. But the other thing that I was talking about, giving you instructions on how to replicate what I did through these tools, that may come at a later time. But what I ended up doing was identified which individual frame, for example, that was related to the splashdown. So you can see this is frame 419, which is going to be, actually, no, this is going to be frame 448. So frame 448 is going to be this one, and I had written down 172 pixels from the capsule to the surface. And this process I found was all over. There were wildly differing values, and I'll explain that in just a second. But I tried to find the darkest spot in the disk, which would have been right around here somewhere. Unlike what I'm going to do for the height, I chose all of the pixels that I could see that were not the background color. So I basically chose the widest part. You can see in the video, as it's tumbling down, it becomes more oval than it is round. So it's kind of tumbling through the air. And Red's Rhetoric did say that this thing that came down was 5 meters wide. So I had measured something like 28 pixels in this case, and I had put down 29.1 in my previous exercise. But the other thing that I wanted to do was to measure the height to the ground. And this is where I kind of had to figure out where was the water line and where was the sky. And as I would look through a number of these images, it seemed that the most common point would have been this edge right here. And you can see that in all of these videos, you've got a square of 8 pixels by 8 pixels. And going on memory, this would mean that each one of these blocks is what they call a macro block. And they derive a mathematical equation to come up with this sort of color pattern. And so when we look at something like this, I would have to guess, based on my previous understanding of video compression, that either the camera or YouTube or both or all of the processes in between have decided that this block that you see here, somewhere in this block is the transition between sky and water. And depending on the color shading, depending on the compression and the lighting and all of that stuff, the water line could be over here, it could be over here, or it could even dip down closer to this, to the start of this block down here. And so I was playing a little bit safe and saying that this was where the water line was. And so I chose basically from this point down to this point, and I had 170 pixels, and I had 172 before. These are extra columns that I added to calculate what the difference was to the previous frame. This was kind of like an ongoing increasing average, so you could see that basically from the start here running all the way down to this one. And so as I kept going, I averaged out all of the frames from the first frame that this thing appeared in the sky to the point that it fell down like this. And in essence, what I did was I measured the distance in pixels between from where the bottom of the Orion rocket was to the surface of the water, marking the frame number down. The yellow cells are the rows that are completely hidden. There's no action. So basically, this is the last frame that the Orion rocket is visible. There are 3 frames in the original video, and then this is the first frame where you get to see some splash. And then I kept going, and at some point, eventually, I saw that it had plateaued. And by this point, the first frames were a little bit hard to do. They were very tedious, but I very quickly learned to import 20 frames at a time as individual layers, like you see here. And then after I had marked each one down, I just deleted this layer, and near the end it was going quite fast. But this value here is where the peak of this one was. And so I tracked this one up, even though there was another one that came up and was even higher than this one. And so in this spreadsheet, that's why I say the highest splash was 270, even though I was tracking 216. So the 216 was the middle of these 3 plumes of water that kind of went up like that. And so once I had gone through and I kind of found where the water had plateaued, when I was able to track the rocket falling all the way down to where it splashed, I then created a scatter plot. I'm just going to delete these temporarily because these are values that I have added or interpolated from the data. So the blue is the height in pixels of the base of the rocket to the water line. And as you can see, it's falling in a straight line, which means that it had already reached terminal velocity at that point, and it was falling down in a linear fashion. Then at some point later, there was a splash, and you could see that the water started off quite fast, and as it was nearing the peak, it was slowing down. over time. And so now the trick is to find out where these two met. And so here's what it looks like. And all I did was I just started playing with numbers. I went minus 10. I could see that minus 10 wasn't quite enough. And then I tried minus 20, and minus 20 was a little bit too far down. I wanted the red dot to be right in the middle of the trend line. And I found that minus 18 was pretty much the ideal candidate. And then, of course, at the same moment, I put the capsule, and then I tried to find the next one over here, which kind of matched the curve, and I did a similar process, and I kind of found that 10 was a pretty good estimate value, so I put it over there. And so basically, what does that really mean? Well, I can pretty much say that at this frame here, the Orion disk had hit the surface of the water at 18 pixels below what I had measured for the horizon based on the image. And whether I'm 2 pixels or 5 pixels or 12 pixels off, it is still a negative number. It's still minus 18. And in reality, it would be closer to right about there. So there's all of this water plus possibly even more water above this. So it really might even be closer to here. We don't really know. There was an inferior mirage. There was refraction. There was all kinds of other stuff going on. But there is definitely at least this much water above the impact point before where the splash occurred. And that's what this graph really intended to show. And I decided to try to do a few other estimates as well. So going through all of the frames where the Orion disk was visible, I don't really know what it's called. I do know that it was the Orion launch. And I think I heard Red say that it was a disk that had fallen off the rocket or something. I don't know. But it certainly looked round in most of the frames. And so I kept taking different measurements, and I got an average pixel count of about 28.8. And if the Orion disk was 5 meters in diameter, that would mean that in the image, 1 meter represented 0.17 pixels. And then from there, I was able to calculate an estimated hidden height. And I added this video macro block compensation because, as I explained, the way MPEG compresses videos, it breaks the image down into 8x8 blocks. And so somewhere in this 8x8 block should be the horizon. And so is it the first pixel up? Is it the fourth pixel up? Is it all the way near the top? So I kind of picked an average of 4 pixels. So in essence, I took the 18 pixels that were below and I added another 4 on top like that. And so that's where this number comes from. And from there, I estimated that there should have been almost 4 meters obstructed due to Earth curve. I even tried to work out a few other things, hoping I could possibly calculate the speed that it was falling, and by my estimation, I suspect that it was falling at a rate of 345 kilometers an hour. I could be off because it was entirely based on these numbers up here, and I kind of estimated that the water had probably splashed up to 46 meters or thereabouts, and it took about roughly 17 seconds for the water to crest and to start coming back down. And coming back to Flatzoid, what I did was I also have a couple of columns. In this one, this is the full extract frame number count. And so, as I explained, I did not want to extract the full 4.5 minute video at 1920 by 1080 as separate images, so I only extracted that portion at that resolution that I wanted. But I did extract at the slightly smaller resolution. I think it was the 1024 by 768. I did extract the full video from that I ended up using to create the time-stamped videos that I'm going to include here. And I did something similar for Flatzoid's video. And so I know that the first playthrough was uncut. And so I looked for the 3 frames in Flatzoid's video where there was no action happening, which would have been this one, and I correlated it to this one. And then all of these other ones are just basically, these are one less than the cell below it. These are all one more than the cell above it. And so I've got sequential counts for both of these. And in the replay where he had cut out the portion where it went behind the curve and it started to come splashing back up, I also went and found that in Flatzoid's video, frame 6990 was the last frame above where the Orion rocket was above the horizon. Then he had cut these 13 frames, and then the next frame was this one, which was 6533 in the original, which corresponds to 6991 in his. And I only captured a few of these at this point. So now what I'm going to do is I'm going to play Red's original video with the timestamps. That's going to be at 1024 by 768 so that you can see more detail. Now I'm going to play the clips from FlatzoidFE where he played the original clip uncut. And then again where he did the replay cut. Now I'm going to play Flatzoid's first playthrough that he did not cut, stacked on top of Red's video. And finally, I'm going to play his replay stacked on top of Red's, and you'll be able to see by looking at these numbers, you can see that he had cut out a bunch of these frames. That's going to be it for now. Thank you for watching. If you like this video, I would appreciate the thumbs up, the subscribe, comment below. You know what to do. And I will see you again in another video soon enough. So bye for now.